Hi guys, you might know I've been doing a little bit of work on some solar lights recently, or solar ornaments. Some of these up here are ones that I've been given by a friend, and some of them worked, most of them worked, and one of them didn't. I've just fixed that. It was just the on-off switch was faulty, in fact. But in the meantime, I have had a comment from Chatty Batty, who suggested I ought to make one of my own, a solar lamp of my own. Well, I do have quite a few bits salvaged from old solar lights, and I've just put them together down here. So that's the battery holder from one of them. It's got a pointy stick. That's an LED from one of them. That's the little controller chip from one of them. And behind it is a little inductor. That's one of my very delicate solar panels, which, as you can see, is just the remains of one. I have broken quite a few of them. They are so delicate you only have to touch them and they break. But I did think it might be fun just to make use of it. Oh, you can see there, sorry about the light causing the flicker. If I turn it over, you can see that the light comes on. So while it's the right way up and we've got the light shining on it, then it's charging the battery, and if we cover it or the sun goes in, then the light comes on. Let's turn that off to stop it flickering. Sorry about that. Yeah, as you can see, the light is on. Now, whether that little solar panel has enough power to actually charge that battery, I don't know. That battery already had some charge in it. But certainly, as you can see, when we get light on there, the charging circuit's working, and when we haven't got light on there, the LED is discharging the battery. So I'll probably leave this now, maybe put it in the window or something, and see if it actually charges up tomorrow when it's daylight. We have actually got a thunderstorm rolling around outside at the moment. It's conveniently gone quiet while I'm filming this bit. But yeah, there we are. That's a homemade solar lamp. Solar panel, controller chip, nickel metal hydride rechargeable battery. That one happens to be a AAA 300 milliamp hour, and that's doing the job. I don't know if I can just turn the flashlight on the camera here. Oh yeah, that does it. So if I shine that on there, is that enough light to turn it off? No. Yes it is. If I shine directly on it, that turns the LED off. Turn it away, LED comes on. So that's just using the light from the camera. Yeah, oh, there we go. I'll draw a little diagram just so you can make one up yourself. Seriously, there is no point in making one up yourself. It's much easier just to buy one of the Poundland solar lights and use the little circuit board inside. But as I was asked, and I got these little bits and pieces laying around, I've put one together from the components. Let's see if I can draw the circuit for you. The chip has got YX8018 written on it. I was looking at a different one the other day, so I think there's more than one version. If I just draw its shape, it's got a bit of a shape like that. And then we got 4 pins. If we just come straight across like this, then the inductor goes right across here. I'll just draw it as a squiggle. That's L for inductor. The LED goes across here. Now I cannot remember which way round it goes. Depending on whether the legs have been chopped already, I reckon it's that way round. The arrows indicate it's a light emitting diode. If I'm wrong, turn it round the other way. The solar panel. What's the sign for a solar panel? I have no idea. But it's actually S plus and S minus, that way round. Over this way, the battery goes on there. Let's make it simple. Let's just say B plus and B. No, I just got that the wrong way round. Oh, typical. That's B minus. That's a very thick minus sign, and that's B plus. And that's it. That is the circuit. Because everything clever is done in that little IC. Basically, power comes in from the solar panel. This integrated circuit either allows the power to go through to the battery and charge the battery, or if there's less power coming in from the solar panel than there is from the battery, then it allows the current to flow from the battery through the LED. So it's coming in that way, and then at one point that S minus has been diverted to the B minus, so it's charging the battery. And then if there isn't enough power here, then B minus is going to the negative side of the LED. B plus is then being switched through to that pin. So I think I've drawn that the wrong way round, but never mind. That's it. There really isn't anything else to it. Oh, the inductor. I'll put some pictures on the video, but it's, I think, red, brown, black, silver on the inductor. Which would be millihenries or something. But that's it. So cover that over, LED comes on. That bit of wire I've got just there is just instead of an on-off switch. so I can disconnect the battery. I just wanted to add a little bit to the end of the video about how this little circuit acts like a jewel thief, which you may have heard of. You may know that a white LED needs about 3.2 volts to light up. It certainly won't light from a 1.2 volt battery. So what is happening? Well, what is happening is that bit of circuitry is in effect boosting the voltage. It's pulsing, flyback and such, so I'm not going to go into the detail, but it's using 1.2 volts to light a LED that would not normally light from a 1.2 volt battery. I think the easiest thing I can do is if I pull that out, use this bit of wire that's going to the positive so I can extend it. So if I just put it onto the tag, it doesn't light up, and if you think I've got it the wrong way round, we'll do it the other way round, and it still doesn't light up. In fact, if I measure that, it's been running for a while and we're down to about 0.7 of a volt anyway. We're not even at 1.2 volts. Oh no, a bit more, 0.9 of a volt. It was down at 0.7 earlier, but it's picked up a little bit because I've got the lights back on, I think. So less than a volt. And yet it's lighting that LED through the circuit. So if I put it back in to the right place and connect the battery back up again, there we go. So if you want to make yourself a jewel thief, you can take a shortcut and do that, and it's doing it for you. If I pull that inductor out, it doesn't work. That inductor is part of the boost circuit, as I'm calling it. Anyway, just thought I'd add that onto the end of the video. Thanks for watching. If you want more information, check down below in the video description. If you like this video, you might like this one up here. And if you want to subscribe, you can check out my channel over here. Up here is my latest video on my channel, and down here is a video playlist associated with the video you've just watched. Thanks again for watching.